We're going to be talking about the mean value theorem, or MVT, and the mean value theorem is a really important theorem in calculus. It's responsible for a lot of the things that we talk about and a lot of the differentiable functions. So to start off, you need to know two things about mean value theorem. The first thing is we're going to have a function y equals f of x, and the function is going to have two things. The first thing is it's going to have to be continuous, and the second thing is it's going to have to be differentiable. So it's important to know these two parts, that it's continuous and differentiable, because a lot of times on the calculus FRQ, it asks how and why a certain function, and how and why the mean value theorem applies to a certain function on the FRQ. So to start off, we have this function y equals f of x. As we can see, it's continuous and differentiable. And at some point, we have 2 points. This is going to be point A. We don't need to know the y value for right now. And this is going to be point B. So from point A to point B, here in point B, and right now it doesn't really matter what these points are. We're just going to be using A and B. So for a normal function, you're going to be, to find the slope, it's going to be f of B minus f of A over B minus A. So that's going to give us the slope right here. So from these points, we know that the average slope is going to be this, whatever this is. And then, so mean value theorem basically says that this slope that we just found, it's going to have to occur somewhere on the graph. So as we can see at this point C, these lines are, this slope line is tangent to the graph, and these are parallel. So that means that they have the same slope at this point. So mean value theorem is basically asking you to find at what point C is the function slope equal to the average slope over the entire A to B. So F for mean value theorem, F prime of C is always going to equal A rock, or the average rate of change. So this is A rock right here. So F prime of C is going to equal A rock. So we can see right there that tangent line is F prime of C, that dotted line is A rock, and they are equal to each other.
All right, welcome back. We're going to do a practice problem for mean value theorem. If you recall, mean value theorem is average rate of change equals instantaneous rate of change. And so first, we're going to find the average rate of change for this function in the interval. If you remember, the function for mean value, or for average value, is when f is f of b minus f of a over b minus a. If we apply the function to this formula, we get find a solution will be 2 to the third minus simple algebra here is 8 minus 32 minus 64 plus 64, so that's just going to cancel out here. So here it's negative 24. And if you remember here, it's b minus a, so it's going to be 2 minus negative 4, so that's 6. So negative 24 over 6 equals negative 4. So I'll just write that down. That's the average value. Alright, now, as we recall, mean value theorem is the average value equals the instantaneous rate of change. And so, first we have to find the derivative of the function, which will be just have to make it equal to negative 4. Again, just simple algebra. X will equal to plus or minus 2. And just make sure that these points fit in the interval, and negative 2 and positive 2 will work.
Okay, so the next topic we're going to talk about is average value, which is also an important topic and often comes up on the AP test. So what the average value states is that you want to add up all the area under the curve and divide it by the interval to find the average value over that interval. So pretty much, so you're given a function f of x, and you have to find the average value, let's just say from a to b. So if the function is continuous over a to b, then you can use an integral to add up the total area under the curve. So from a to b. And then, so this gives you the total area or the total value of what you're trying to find. And then you divide it by the interval, so b minus a. And that will give you the average. So if you draw a graph, show it graphically. If this is your graph, f of x, and this is your average, b minus, or whatever this is, a to b. This integral with divided by the interval is going to give you this area right here, which is the average. So usually the average value is used, so say you're given a velocity function, you have to find average velocity. You're going to use this to find the average velocity over that interval. Or if you're given a rate and you have to find the average rate, you're going to be using this.
Welcome back to AB Calculus AB. I'm going to do a practice question on average value, now that we learned how to do it. So to begin with, the question is, what is the average value of f of x equals e to the x on the interval 5 to 7? We know the formula for average value is 1 over b minus a, and the integral of from a to b of f of x. So what is b minus a? What does b and a stand for? B and a are the two bounds of intervals. So we know that b is 7 and 5 is, or a is 5. And the integral of f of x from a to b shows the total area under the curve of f of x equals e to the x. So if e to the x looks something like this, 5 to 7, we'll know that the integral will give us the entire area underneath the curve. And if we subtract b minus a, it will allow us to take the average. So let's apply that to solving the problem. Average value equals 1 over b minus a, and the integral of 5 to 7. So here, e to the x is f of x, so you take the derivative of that. Or you put d of x for that. And without a calculator, we won't know what e to the 7 and e to the 5 is. And so, sorry, the integral of e to the x, these bounds, will be e to the 7 minus e to the 5 over 7 minus 5. Right? If you want to simplify this question, if there's a multiple choice question, you need to figure it out. You can therefore say that e to the 7 minus e to the 5 over 2.
Okay, so the next topic that's also important that we're going to be talking about is how to find derivatives of inverse functions. So this sounds pretty complicated, but once you figure out the formula, it's a pretty simple process to find the answer. So you're given that g of x and f of x are inverses, so you know that they're going to have opposite x and y values for their points. So say you want to find the derivative of g of x at a certain point, and you know that f of x is its inverse. The formula would be g prime of a equals 1 over f prime of b. So that's pretty much the formula. So you just have to set up your equations so you know what the points of f are and the points of g are, and that they're inverses. And once you find that, then you just plug in and then you solve for the derivative.
Hello, fellow Foothill students. Welcome to AP Calculus AB. Today we're going to be doing a practice problem for derivatives of inverse functions. As Emily Haskell taught us, h prime of a equals 1 over g prime of b. So we know that g of x is equal to the inverse of h, and our goal is to find h prime of 3. So we know that h of 3 equals 4, therefore g of 4 must equal 3. So by that thought, so h prime of 3 equals 1 over g prime of 4, which equals 1/2. So g prime of 4 is 1/2, so equals 1 over 1/2 equals 2. And that's what h prime of 3 equals.
Okay, so the next thing we're going to learn is derivatives of inverse trig functions, and as Buddy will show you in the example, you can solve for these derivatives using implicit differentiation using right triangles, but in tests and during the AP tests that will take a lot of time if you try to solve it every single time there's one of these problems. So it's important just to try to memorize these inverse trig functions, and although it might seem hard, all you have to do is memorize 3 functions. Really, so one important one is sine inverse, which is 1 over root 1 minus x squared, tangent inverse, which is 1 over 1 plus x squared, and secant inverse, which is 1 over absolute value of x times root x squared minus 1. And once you have these memorized, all the cos, so the cosine, cotangent, and cosecant, it's the exact same, but just with a -1 instead of a +1. So once you memorize these, there will be a lot of problems where, especially in integrals, where these will come up, and it's important to memorize these inverse trig functions so that it just makes the work easier and it saves you a lot of time in the future.
Hello, Calculus AB students. Today we're going to be doing a practice problem for derivatives of inverse trigonometric functions. Okay, so let's start. We have the function y equals inverse sine of x. So let's start off by multiplying both sides by sine. So now it's sine y equals x. We all love hypotenuse. We all love 90-degree triangles. Right angles are a beautiful thing. Here we go. Got a right angle here. We'll call this angle y. So we know that it's opposite over hypotenuse. So this is x over 1. Now let's use beautiful Pythagorean theorem. X squared plus, we call this b squared equals 1 squared. So b squared equals 1 minus x squared. B equals root 1 minus x squared equals root 1 minus x squared. Who doesn't love implicit differentiation? Take a derivative of both sides. Cosine y dy dx equals 1. Divide by cosine y, cancels out, divide by cosine y. dy over dx equals 1 over cosine y. Let's plug it back in. What's cosine of y? Adjacent, root 1 minus x squared over 1 equals 1 over root 1 minus x squared. That's how you find the derivative of sine inverse of x, baby!
So we're going to be doing a practice problem for derivatives of trig inverses. So as I said before, these trig inverses are really important to just memorize, because when you do these problems, it'll just be a lot faster if you know them. So I know that the derivative of sine inverse is 1 over square root of 1 minus x, but since 2, we have to plug this in for x, because we're doing the chain rule. So 2, this is the inside function, so 2x squared plus 1 squared. And then since this is a chain rule, we have to multiply by the derivative of the inside function, which is 4x. So the final answer will be 4x over 1 minus 2x squared plus 1 squared, all under the square root.